giant pieces of rocks, like pieces of puzzles. The pieces of rocks are called plates, what form continents and ocean floors.
Where the edges of the plates come together around in cracks and gaps. These cracks and gaps are called faults.
Underneath the plates, the earth is extremely hot, and it's so hot that rock turns into a liquid called magma. Plates go on top of this liquid magma, which is always moving.
As the magma moves, it drags the plates around with it. Three distinct things can happen at the edges of moving plates. Plates that move past each other can grind edges. Plates that are moving apart can make a gap where magma sits out. Three distinct plates that are moving apart can make a gap where magma sits out.
Plates usually very thin when they get caught in each other, and they keep trying to move. Pressure and energy builds up inside the moving.
Pop, crack, move!
Plates give away. As the plates jerk forward, the ground trembles and it shakes. And far above, on Earth's surface, people feel an earthquake. Some earthquakes are small and some are much larger and frightening.
How can you tell the difference?
Small earthquakes cause the ground to shake just a little, causing hanging objects to swing and tree branches to sway, much like in a gentle breeze. Big earthquakes cause the ground to shake so hard buildings crumble, bridges collapse, and large cracks up in the ground.
An earthquake can be measured. We use an instrument called a seismograph. Measures an earthquake. The quake is giving a number from the British scale.
People can't feel an earthquake that measures 1.0, and they usually can't feel a quake that measures 2.0, but people can feel a quake that measures 3.0.
Is there damage? No, but some weak buildings might be damaged before an earthquake, which people definitely feel near the origin of the earthquake.
At 5.0 and 6.0, a quake can be felt over a wider area and cause lots of damage to weak buildings and some damage to strong buildings. This kind of quake can be scary.
Really scary? 7.0 quake is major. Most buildings in the center are destroyed. Cracks from under the earth, underground pipes break, and landslides may occur.
An 8.0 earthquake is even worse. Buildings and bridges are destroyed, large cracks appear on the ground, large landslides occur too. At 9.0, the ground appears to move in waves. Entire rivers can move, objects can be thrown into the air, buildings and other structures can totally be destroyed.
Amazing. What else can you tell us about?
Let's turn our attention to another violent force, volcanic eruptions. A volcano occurs when magma from deep inside the earth can come out through a crack in the surface. Volcanoes usually happen near plates. There are many cracks and thin spots.
Magma leaks out of the cracks and thin spots.
It pours into land, hardens, and then forms mountains or islands.
Other times, magma cools before it gets to the surface. It hardens into a piece of rock that plugs up the crack where it had been seeping out.
The magma continues to push upward against the hardened rock plug. Hot gases increase and the pressure builds. Huge chunks of rock burst from the volcano. Kaboom! Mountainsides can be ripped away when a volcano erupts. Hot gas, ash, and melted rock shoot into the sky. Tons of rock roll down the mountains. These walls of rock falling rock are called landslides. Can bury whole cities and block nearby rivers from flowing, causing floods.
What else happens? Clouds of ash and dust rise into the air during volcanic eruptions. The ash falls to the ground like a huge snowfall. The heavy ash could cause roofs of houses to collapse. An ash cloud can actually spread all around the world. Incredible.
What else can happen?
Large ash clouds can even block out the sunlight, and the temperature of the entire Earth can cool down after an eruption. The explosion can be so great that it knocks down entire forests. Destructive fires can start. Some gigantic volcanoes have some snow and ice on top. Hot gases from the eruption melt all the snow and ice, causing water to rush down the mountainside. The large dirt-filled flood is called a mudslide, which is really just a liquid landslide.
We can't always predict an earthquake, but we can predict a volcanic eruption. People can find safety. Lives can be saved.
Is there more?
Final force the scientists will describe today is a tsunami. Tsunamis are huge waves that can be caused by earthquakes or volcanoes and are the biggest waves in the world.
That was so big.
Tsunamis can be as high as a football field is long. Let's find out from the scientists and lab technicians what causes these monster waves.
The edges of a plate where the earthquake and volcanoes occur are often near oceans. The power of these two forces can cause landslides to fall into the sea and make huge waves.
Earthquakes can occur underwater. They can cause sea levels to move violently.
Volcanoes can occur under the sea too. They cause explosions underwater.
All of these forces, landslides, and shaking sea floors called tsunamis. Tsunamis speed outward, moving away from their sources in all directions. A tsunami can cross the entire ocean at 200 miles an hour.
That's really fast.
Tsunamis may not appear high above the surface of the water, but they are very deep. As tsunamis approach land, they move into shallow water, and the ocean floor pushes the wave upward. The wave slows, the ocean floor lifts the wave.
Higher and higher.
When a tsunami reaches land, it can destroy almost anything in its path. The tallest tsunami on record hit Alaska's coast and was as big as the world's tallest building. Most tsunamis are not that big when they hit land. Often tsunamis are between 1 and 10 stories tall.
That's still tall.
Sometimes we can warn people when tsunamis are about to hit land.
We might have a few minutes or a few hours so lives can be saved, although houses might be lost.
Like a quiet planet, we know it's vital. We'll keep learning more about earthquakes, volcanoes, and tsunamis. It's our job, and we want to keep